Welcome to the video notes for section 8.3.1 called Polynomial Division. Our objective for the day, I will learn how to use polynomial division to find the factors of a polynomial. And I know that I am successful when I understand the rules of PolyDoku, looking forward to finding out what that's all about, and master the checkpoints. So first of all, some vocabulary, and this word we have today is a word you know already. It's called factor. And another way to define the word factor is that it is part of a product. So as an example, we want to find the factors of 3x squared minus 9x plus 6. So the first thing that we're able to do is to factor a 3 out of every term. When we do that, we're left with a 3 on the outside times x squared minus 3x plus 2. Then we can further break that down by leaving the 3 out front, creating two sets of parentheses. An x goes in the beginning of both sets of parentheses. On the other end, we have to multiply to be 2. And we have to have a middle term of negative 3. So I'm going to use a negative 2 and a negative 1. So if I would FOIL that to check to make sure that I factored correctly, I have a negative 2x on the inside and a negative 1x on the outside. Those do combine to be negative 3x. So we know that we have the factors correctly identified for this polynomial. What's the difference between a factor and a root? Well, if a is the root of a polynomial, then x minus a is a factor of that same polynomial. And if x minus a is a factor, then a is a root. So again, a root is the same thing as an x-intercept, same thing as a 0, same thing as a solution. That's something we can identify from a graph. When we turn it back into a factor, then those factors can be multiplied together to give us that polynomial that we started with. So let's take a look at another example. This one is x squared minus 5x minus 6. And so in order to factor it, again, it's a quadratic, so I write my two sets of parentheses. I put an x at the beginning of each. The other end has to multiply together to be negative 6, and I need to have a difference in my terms of negative 5. So I'm going to go minus 6 and plus 1. So again, if I would FOIL that to check, I would get negative 5x on the inside, positive 1 on the outside. Those do combine to be a negative 5x. In order to find the roots, I use the zero product property. So I can set each one of these factors equal to 0. And then when I solve for x, I get my roots, or I get my solutions. I get x equals 6 and x equals negative 1. And those are called my roots. Now, there are times when it's a little bit tricky to find the factors when you are given the roots. In particular, when you have a complex number that's your root, and that's something that you've seen in the last couple days in class. So as just kind of a helpful hint here, when you're trying to write a factor from a root, we can always subtract the root a from x to create a factor. So as an example, if the root is x equals 4, then the factor is x minus 4. If the factor is x equals negative 3, I can still subtract it from x. I can go x minus negative 3, which is x plus 3, which is what we know it to be. So it's always okay to go x minus whatever the root is and simplify from there in order to figure out the factors. Sometimes that's going to be helpful to you. So now the question becomes, how do we find the factors of a polynomial that's something other than a quadratic? For example, we've got 6x cubed minus 23x squared minus 13x plus 70. So here's the steps that we go through in order to find all the factors of that. So first of all, we're going to graph it to find a 0. And again, remember, a 0 is the same thing as an x-intercept or a root. So let me pull our graph up for us here. I've typed in the equation as it was given to us. And set up the window according to what's in the middle of your screen. You can see there. And when I hit graph, this is what the graph looks like. You'll notice that I have 3 x-intercepts, which means I have 3 real roots. But there's only one that I can read and kind of evaluate for sure. And it looks to me like there is an x-intercept at x equals 2. We can verify that by hitting our trace button and then typing in an x-coordinate of 2 and seeing what the y-coordinate is there, and we find that the y-coordinate is 0, so x equals 2 is, in fact, an x-intercept. Once we have that x-intercept, now we can go back to our notes here. I'm going to write down for us that we have x equals 2 as an x-intercept, or as a 0. So now we're going to change or turn that 0 into a factor. So again, if x equals 2 is the 0, x minus 2 is the factor. Once we have that factor, this is the new part now of this lesson. From here, in order to find the other factors that go with x minus 2 for that polynomial, we're going to divide the given polynomial by the factor to find another factor of the polynomial. So now at this point, if you're going, huh? Let me help you understand this in terms of just integers. Let's say that I ask you to give me a factor of 24, and you told me that 3 is a factor of 24. So I said, okay, 3 is a factor of 24. How do I find another one? How do I find the one that goes with the 3? And you tell me, well, I can take 24 divided by 3, and I get 8. 8, therefore, is another factor of 24. That's essentially the same thing we're doing now with polynomials. So we're going to take the factor that we know and divide it into the polynomial that we were given in order to find us another factor of that polynomial. So that's our plan from here on out. In order to do that division, we have a method that's called Polydelku, and it's just like Sudoku. It's kind of named after that because we're filling in boxes. And so this is a method of dividing polynomials. So I want to show you how this one works out. So we're going to first of all take that third degree polynomial that we were given, and we're going to write that in the bottom. And we're going to, and actually, you know what I need you to do? I need you to first of all make a drawing in your notes like the one that you see here. So go ahead and pause the video to give yourself a chance to make a drawing like I have here, because it's important that you put this example and the next couple examples into your notes. So go ahead and pause the video if you haven't yet drawn that onto your notebook. All right, so from here, now that we have this drawn, now we need to label some things. We know that, again, going back to what our equation was, this was our 6x cubed minus 23x squared minus 13x plus 70. So we need to kind of put that in our picture. And the way that we do that is that we line up, we put 6x cubed out here. Then we put our minus 23x squared. Notice that I'm kind of going to line up some of these numbers underneath the vertical bars above them. Minus 13x plus 70. So we label that on the bottom. That's our given polynomial. On the left-hand side vertically, I'm going to put the factor that we found, the x minus 2. Up here, I'm going to put a multiplication symbol up in this corner. That's just times. And every time we do this, you're going to put a multiplication symbol up there. Now, what I'm trying to do, and just so you kind of ultimately know how this is going to work, is what I have with the x minus 2 is going to get multiplied by what I have across the top here eventually to give us this 6x cubed minus 23x squared minus 13x plus 70. So that's kind of how this is going to happen. So let me show you the process. We start out by taking the first term of our resulting polynomial, and that goes here. Now from here, this is like our boxes where we were multiplying along the sides to fill in the boxes. So I'm going to say x times what gives me 6x cubed, and that would be 6x squared. So now I know that 6x squared times x gives me 6x cubed. Now I go down to the box below that, and I want to say 6x squared times negative 2 gives me negative 12x squared. Now from here, you need to look at the bottom. You need to look at the polynomial that you're given, and you notice that we need to have negative 23x squareds. Right now I have a negative 12x squared. I need to know what I need to do to this x squared term here in order to get to the negative 23x squared. And what I need is an additional negative 11x squared. So I put that up here. And you'll notice that diagonally, I've got my x squared terms that will give me the negative 23x squared. So those two diagonal boxes should add together to give me the number of x squareds that I have at the bottom. So negative 12x squareds and negative 11x squareds is negative 23x squareds. Now I start the process again. What did I multiply x by to get to negative 11x squared? And that was a negative 11x. So that goes up on top. The negative 11x gets multiplied by the negative 2, and I get 22x. Now I look back at the bottom at my x term, and I know that I need to end up with negative 13x. Right now I have 22x. So in order to get that to the point where I have negative 13x, I'm going to have to subtract 35x. Because now 22x and negative 35x combine to give me negative 13x. So now I start again. What does x have to get multiplied by to be negative 35x? And that would be a negative 35. Negative 35 times negative 2 is positive 70, and that should agree with what we have down here, and it does. And that indicates that we have no remainder. There may be times coming up in the future when we will have a remainder when we divide, but the way that it works is if we're dividing by something that we know is a factor, we should always come out with a remainder of 0. So here's how we write our answer. We know that x minus 2 is a factor. Another factor is 6x squared minus 11x minus 35. If we were to multiply those together, we would get this polynomial that we had started with. Okay? So the other factor we were looking for was this one, the 6x squared minus 11x minus 35. Let's try another one. Again, take a moment to pause the video so that you can draw the picture of the PolyDoku grid on your paper. Now we're going to find the roots of x cubed minus 28x minus 48 if we're given that x plus 4 is a factor. So this time we're given what the factor is. So instead of graphing it and finding that 0 at x equals negative 4 and then turning it into a factor, we're giving you the factor right away. So again, now let's write, kind of set up our PolyDoku game board here, if you want to think of it as that. So underneath here, I'm going to have my x cubed. And notice actually in this one, what we have to deal with, we don't have an x squared term in the polynomial that we're given. When that happens, and it's only in the polynomial that we're given that it's an issue, but if we're missing an exponent, like going from 3 down to 0, from wherever you started down to 0, you have to fill in that spot with a 0 coefficient as a placeholder. So in other words, I'm going to go plus 0x squared, and then we're going to have minus 28x, and then minus 48. Okay. And then along the vertical, the left side vertically, I'm going to put my x plus 4. So here's the x plus 4. Again, up here in the corner, I want to remind myself I'm multiplying what's underneath it by what's next to it in order to get the polynomial that I was given. Okay. So again, we take what we have initially. We've got the x cubed as the first term, and that goes here. So now we say x times what gives us x cubed, and that has to be an x squared. So again, x squared times x gives me x cubed. Now I multiply the x squared times the 4, and I get 4x squared. If you look underneath, I need to end up with 0x squared. So now I need to put in the box diagonal from the 4x squared what I need to have or what I need to add to the 4x squared in order to get me to 0x squared. And that would need to be a negative 4x squared. So now when I add my x squared boxes, I get 0x squared, which is what I need at the bottom. So now above that, I say x times what gets me negative 4x squared, and I need a negative 4x, so that goes up above. The negative 4x gets multiplied by the 4, and I get negative 16x. So now I check below to see how many x's I need to end up with, and I need to end up with a negative 28x. Right now I have a negative 16x. So I need to add to it a negative 12x, and I will get negative 28x. So that's what goes in that box. So now again, to find what goes above it, I say x times what gets me negative 12x, and that's a negative 12. And negative 12 times 4 is then negative 48, which is my constant at the end. So we know that, again, we divided correctly and have a remainder of 0. So find the roots. We need to do a few steps here. What I found so far was that x plus 4 times x squared minus 4x minus 12 is sort of the first level of factoring for the given polynomial. Now, our job is to find roots. So I want to break down my factors as far as possible and then hopefully use the zero product property to find my roots. You'll notice that this other factor is a quadratic and it can be factored further. So I'm going to factor this, x and x. The negative 12 on the end is going to get broken up into a negative 6 and a positive 2. That would give me a middle term of negative 4. And now I can set each one of these equal to 0. And it's also worth noting that this is the complete factored form of this polynomial. So if the question ever says to you just factor this completely, you stop at that point. If it says to find the roots, then you set each one equal to 0 and solve for x. So these then are our roots. We'd like to do a quick check now to see how well you're doing at this PolyDoku process. So I'm going to have you find the factors of 6x cubed plus 17x squared minus 4x minus 3. Again, given that x plus 3 is a factor. So we took care of graphing it for you and finding an x-intercept and turning it into a factor. So that part was taken care of for you. So again, please pause the video and try this problem on your own to see if you're able to, and then come back and watch me work through it to check your work. All right, welcome back. In order to do this problem, again, along the bottom, I'm going to write out the polynomial that I'm given, 6x cubed plus 17x squared minus 4x minus 3. And I've got my big multiplication symbol up here. I'm given that x plus 3 is the factor that I'm dividing by. My first term is 6x cubed, so again, that goes there. So now I need to get the number that's above it, or the term that's up above it. So I say x times what gets me 6x cubed, and that should be 6x squared. The 6x squared then gets multiplied by the 3 to give me 18x squared. So now I look below to find out how many x squareds I'm supposed to end up with, and I'm supposed to end up with 17. Right now I have 18. So what I need to add to that is a negative 1x squared. So now 18x squared and negative x squared combine to give me a positive 17x squared, which is what I need. So then I ask myself, in order to figure out the number up above, or the term up above, I say x times what gets me negative x squared, and that's a negative x. So then we take negative x times 3, and we get minus 3x. That goes below. So I look to see how many x's I'm supposed to end up with. I'm supposed to end up with a negative 4x. Right now I have a negative 3x. So I need to add to that another negative x. So then x times what? It gets me negative x. That would be negative 1. So that goes up above. And then negative 1 times 3 is negative 3, which again is what I should end up with as my constant term at the end if I divided correctly. So now my factors, so my first level of factoring, are x plus 3 times 6x squared minus x minus 1. And again, we want to find the factors like down to linear factors. In other words, we want to factor completely. The x plus 3 can stay like it is. This one, we're going to break up into 2x in the front and a 3x. Then need a minus 1 and a plus 1. I'm going to put the minus 1 with the 3 and the plus 1 with going with the negative, or with the 2x. So now I have a negative 3x in the middle plus 2x on the outside gets me my negative 1x in the middle. This now is completely factored. Those are the factors of my polynomial. So that's helpful for finding further x-intercepts or further solutions. So hopefully this kind of brings us to the point where we're closing. And so what we should have gotten out of our lesson today is being able to divide a polynomial by a factor that we either find ourselves or are given. in order to completely factor that given polynomial down to linear factors, or to help us find all of the roots. So please wrap up your notes, and I hope you learned a little bit, and we'll see you tomorrow.